Okay. So welcome everyone. My name is Michelle Crawford with the MDE Stormwater, Dam Safety, and Flood Management Program. And with me today are Program Review Division Chief Stu Comstock, Pat Depkin, Devin Kosiski, Andrew Tago, Program Manager Jennifer Smith, and Deputy Program Manager Ray Barr. We review local jurisdictions delegated to inspect and enforce erosion and sediment controls at active construction sites. So we've had the pleasure of meeting many of you already, and there are also several people here we haven't yet met in person. We extended this invitation to all delegated erosion and sediment control local programs and all soil conservation districts across the state, and that's whether you work with a locally delegated program or whether you coordinate directly with our compliance program for inspection and enforcement. And we've also invited the compliance program here, so many of them are also attending, and we welcome you. And we've also invited all NPDES Phase 1 MS4 permitted jurisdictions because our topic today bridges these two subjects, controlling sediment during construction, all the way through to after construction is complete and the site is fully stabilized so that stormwater best management practices operate as they're designed. Today, we'll discuss the guidance that we're preparing and we'll answer your questions and hear your comments and feedback. The document is not finalized, but the overall message and the information that you'll hear today represent our policy, which can be applied immediately. So today and in the coming weeks, we welcome your feedback, your thoughts, your questions on this topic as we put the final touches on the document. So we're going to start with some brief opening comments from Stu Comstock, our division chief, and then Pat Depkin will launch into our discussion and apply his expertise to guide us through this topic. I'm your moderator, Michelle Crawford, and assisting us with corralling your questions and comments is Devin Kosiski. Everyone's microphones are turned off during the presentation. We have a big group here today, which is very exciting, but we welcome you to ask questions throughout this session. And there are some quick breaks that we've built into Pat's presentation, so you don't have to wait until the end to type in a question. To ask a question, there are a couple steps you need to do, and we've tried to break it down here on this slide to show you visually. So in the bottom right corner of your meeting screen, click on the cluster of three shapes. That's the triangle, square, and circle. And it'll open the activities box with the list of options. Click on the Q&A option, and then another box will pop up, and click on Ask a Question with the plus sign. You can type in your question in the box that pops up, and you can click Post to send it to us. And Devin is standing by to gather those questions and make sure they're all answered. If you're having any technical difficulty with that, you can also just raise your hand by clicking on the button at the bottom center of your screen, the little hand shape. And failing all that, if that's not working, you can just try to enter your question into the chat box. So bottom line, we'll try to make sure everyone's questions are answered, and we want to promote a healthy discussion today. But before we launch into our discussion, Stu Comstock has some quick business he'd like to make everyone aware of.
Michelle, excuse me, thank you. So my voice lasts this afternoon. First of all, I want to welcome all of you who are attending today. This is quite a big audience, and I thank you for your time and patience. Second, I want to just add that the Program Review Division and the Stormwater, Dam Safety, and Flood Management Program oversee statewide implementation of the erosion, sediment control, and stormwater management programs. And the topics we're going to discuss today overlap both of those programs, so it's a very timely discussion. But I have one bit of business that I wanted to bring up that is aside from today's topic, but I wanted to get across to the audience today. In many cases, both in the Stormwater Design Manual and in the Erosion 2011 Standards and Specifications for Soil Erosion and Sediment Control, there are materials used for the construction of BMPs, or in this case, for the clearing, grading, and stabilization of a site. And in several cases, there are specific materials mentioned or that are required. And we just want to remind the community at large and you guys, especially those who are out in the field doing an inspection and enforcement, that where a specific material is mentioned or required to be used, you guys should be, looking out for that. It is important that, it was important enough that that material was specified for a reason. And we think that it's important that those specified materials be used over cheaper or maybe inferior alternatives. So if you're out on a site and you see a material being used, feel free to ask for the tickets, showing that they're using the right materials. That's all I got to say, and I'll turn it back over to Michelle and Pat. Thank you.
Thanks, Pat. I'm sorry. Thanks, Stu. Ready for Pat. Now to lead our discussion and provide an overview of our forthcoming guidance is Pat Depkin. Pat, I'll let you introduce yourself and start us off.
Well, thank you, Michelle. Really pleased to see the turnout today. I think this is an important topic, and if we can get things a little dialed in a little better, we're going to see a lot better performance in long-term, specifically long-term performance out of some of the newer BMPs and the practices that are getting installed throughout the state today for the treatment of stormwater runoff. Quick little background. I spent about 20 years as geotechnical consultant in the private engineering sector. First set foot on a job site way back in 1989. So I had the fortunate experience to not only be present on a lot of very different and interesting construction projects, but I also built up, developed, and ran the soils lab for one of the companies and kept that going for while I was there. So I guess you could say I know dirt. I hope so anyway, after all this time. After my time with the geotechnical consultant, I went to work for an outfit, another consultant basically, whose exclusive focus was on stormwater management. Maintenance, inspection, some new design, but mainly inspection, writing inspection reports and recommending maintenance practices to keep these things rolling. I've been with MDE since 2015, so that's about 8 years. It's a little different world here, mostly desk time versus field time, but I've tried to bring my best attributes to it and hopefully make the program a little bit better. So that's me. With that, let's move along. Okay, so as Michelle said, we go around from time to time and look at the various delegated jurisdictions, both from a stormwater capacity as well as a sediment control capacity, and see how their programs are running. Excuse me, and determine if if they're keeping up with the specs and they're following the proper procedures and protocols. Again, all in the interest, at the end of the day, of making sure these facilities go in right, are installed properly, and give us the performance that we're looking for with the minimum amount of maintenance that we could get away with. The better they're built, the better they're constructed, the longer they're going to last, and the less maintenance, hopefully, they'll require. Everybody's got a budget. Everybody's got a budget as far as time and assets and dollars. So the more efficient we can be with that, the better off the community is going to be. So what specifically is the problem that we're looking at or that we're seeing? And let's talk about filters for a moment. This presentation is going to speak specifically to the best management practices that contain a filtering component. Okay. Now, we deal with filters all the time. We have them in oil filters in our car, air filters in our car, coffee filters, vacuum cleaner filters. We're all familiar with the concept. Well, a filter can't work if it gets clogged up. And that's really the bottom line. Once a filter is clogged, whatever medium, and I use the word fluid here, and air is a fluid, water is a fluid, anything that's a fluid can't get through the filter. So it bypasses or it goes around, and we lose the functionality of that filter. In stormwater management, if we allow sediment-laden runoff to get into our filters, they're going to clog up and they're not going to work. So the objective of this presentation today is to talk about some of the practices that we can utilize to prevent this from happening, some of the opportunities where it can occur, and how to best deal with it, and hopefully build a product that's going to last a long time and cost as little as possible from a maintenance perspective. Next slide, please. So what do we got out there that are filters? Well, as I referred to, a lot of the Chapter 5 practices specifically are filters. And we've got our examples here of dry wells, surface sand filters, bioretentions, micro bioretentions, etc. I'd like to mention also, not listed here, some of the proprietary practices, and these are typically undergrounds in the storm of storm filters, jellyfish, the tree boxes. All of these, again, at the end of the day, are filters. And we want them to filter what they're designed to filter and make sure that they don't get clogged up or otherwise compromised by sediment-laden runoff, during construction and afterwards before the site is fully stabilized. Next slide, please. So what makes them filters? Well, again, these practices, as you all are probably familiar with, have a lot of filter media in them, okay? And this could be any number of components to include the planting soil or bioretention soil mix. One point, our manuals have several different names for this stuff, and it's all the same material. To be clear and to clarify, if you go to the materials appendix, the specification for the bioretention soil mix or planting mix is laid out. So that's where you can find that information. But we also get, C33 concrete sand, various aggregates of different sizes from pea gravel up through number 2 stone. And the objective is to take the runoff, the stormwater runoff from a site, run it through this filter media, remove the pollutants and contaminants, and in some cases, reintroduce that filtered water back into the groundwater table via infiltration. Some people call it infiltration. It could be referred to as the recharge component. The bottom line is after the runoff gets through the filter media that we've installed, it's either going to continue to be filtered somewhat by the existing soils, or it's going to be collected in an underdrain system and discharged to daylight or back into the storm drain system somewhere. So we need to make sure that, again, that our filters are filtering what we want them to and not doing double duty, picking up things like muddy runoff and sediment that's carried in muddy runoff. Next slide, please. So this is what we're seeing. And this is the problem that's giving us a little bit of concern. Well, actually, quite a bit of concern. As we go around and do our reviews, we keep seeing facilities that are allegedly protected utilizing filter cloth in the form of silt fence or in the form of filter cloth laid over the material bed after the fact. And I've got a few more photos here that are going to illustrate that. As you can see on the left, the silt fence, the first problem is silt fence is a filter itself. It is not a diversion practice. So you can pass muddy water through silt fence and it's still going to be turbid on the downstream side. Silt fence allows, very small particles to pass through it. If it didn't, it wouldn't be a filter. So the objective here is to keep these fine particles out of our filter media and out of our facility subgrade to keep them clear of contaminants. And again, the photo on the left, a whole lot of effort went into filling that basin in with various layers of media, and the surrounding areas are not stabilized. The silt fence has just been knocked down by the energy that's being directed against it, and all that media is now contaminated. That it needs to be completely removed and dug out to restore this to functionality. The one on the right, we haven't put any media in it yet, but again, if there's an infiltration component, if this excavation is supposed to recharge the groundwater table, again, we've sent all sorts of dirt and fine sediments into our presumably infiltratable subgrades. And again, it's not going to work. It's going to need to be addressed, cleaned out, and otherwise we're going to have to spend some effort making it right again. So the manuals, or the stormwater manual specifically, is pretty clear that when these facilities are installed and the surrounding drainage areas are not 100% stabilized, we need to divert the muddy runoff around them. Next slide. Got a couple more pictures here. Again, in this case, we don't have silt fence around the perimeter of the BMPs, but we do have filter cloth laying on top. Again, in this case, all the filter media and the under drains have been installed. It's in there. And yes, granted, there is seed and straw down on the drainage area, but it's not stabilized. One good thunderstorm and these things are going to be inundated. And you can even see in the example closest to us, the filter cloth has all kinds of dirt and soil and whatnot on top of it. And again, the fines, the clays and the silts that migrate through that filter cloth is going to compromise our facility and potentially compromise the underlying soils that may or may not have an infiltration component or a recharge component. I think we got one more example here. Yep. Now this one, they've done it twice. They've put silt fence around the perimeter and they've laid filter cloth on top. But again, this doesn't meet the intent of the regulation, and it is allowing fine particulates to get in here, and it's going to shorten the service life of this facility if it functions properly at all from the get-go. Next slide, please. Okay, we've got a little discussion point here, and if we've got any questions to entertain, let's have it, Devin.
Yeah, thank you, Pat. It looks like we do have one question here. Brian Hopkins submitted a question in the Q&A. His question is, could submerged gravel wetlands also be considered a filter? It seems like it would be prudent to not let the voids get clogged by sediment. Otherwise, the pollutant-laden water won't be able to trickle down through the biomass-coated media, but will instead bypass through the spillway.
That's exactly what we're talking about here. And absolutely, that's correct. The submerged gravel wetland is acting as a filter in addition to the biological component that's going on. And we're going to talk about submerged gravel wetlands a little bit further on in the presentation, because I think there's some, again, based on what we're seeing, there may not be a fully clear understanding of how submerged gravel wetlands work, and when they need protection and when they do not. And again, we'll speak to that a little further. But the point is valid. If you clog up all that expensive media with muddy runoff from the site, then the facility's not going to operate properly. Again, I'm going to speak a little bit more about submerged gravel wetlands and when it's appropriate to throw protection on them, and when they could sort of be left to themselves. So hopefully that speaks to that. And again, we're going to get back to SGWs here in a little bit further in the presentation. Anything else?
Thank you, Pat, for that explanation. So yeah, we'll take a little bit more time, maybe let some others develop some of their thoughts if anyone else has a little bit more questions. We will have another slide like this later on in the presentation towards the end. So if any of you guys are thinking about any more questions or have some that pop up afterwards, we will have a little bit more time, and as well time at the end of the presentation to answer the questions. We did just get another one from George Holmes. His question is, what construction methods you recommend to address this concern?
We're going to get to that. That's really the bulk of this presentation. Right now, I'm just sort of laying out the scenarios that we're seeing, and we're going to speak to how to deal with them and the best practices to deal with them. I think I saw Stu may have had a point to make.
I did. I wanted to go back and just briefly touch on the submerged gravel wetlands, just briefly. Because they are actually a horizontal flow filter, not a vertical flow filter, you're right. The biomass coated media, the gravel is what's filtering the pollutants. what we're finding is that when the lines get into the facilities and trickle down to the bottom, it seals the bottom of the facilities or the sides of the facilities, and not necessarily because the gravel media is not in place in the submerged gravel wetland during these constructions, as Pat will show you later, then it's not getting as clogged by the sediment. So that's one of the reasons why it may be handled differently, as Pat will talk later.
Thanks, Stu. If there's nothing else right this minute, Devin, let's go ahead and jump to the next section.
Sounds good, Pat. Let's go ahead and continue.
So we've laid out what the issues are that we're seeing. What are the rules? What does the book say about this? What are our regulatory requirements? And I'm not going to read this. You all are perfectly capable of reading it, and it is in the design manual. But the gist of what we're driving at here, and the gist of what the regulations say is, if you've got an infiltration practice and it's specifically intended to infiltrate, you can't use that as part of your sediment control practices. Okay, we do not want to use any facility that has an infiltration or a recharge component as a sediment trap per se. And again, highlighted in red, the erosion and sediment control plan for the site has to clearly show how we're going to keep sediment-laden runoff out of our facilities. There's nothing new here. This has been in the book since the book was published in 2000 and updated in 2009. I will say that the sediment and erosion control manual does not speak to this. So again, we're kind of jumping back and forth between two disciplines, but in this particular case, they're united. They can't really be separated. And the second bullet point here just says Chapter 5 in the design manual, stormwater manual, adds a little more detail to this. And pages 5.510 through 516 speak pretty specifically on the topic. So again, go back and review these sections. I'm going to talk about it, but that's where the material lies that we're drawing this from. Next slide, please. And some more rules. So any practice in Chapter 5 that involves a filtering or infiltration component has the following caveat or warning or other, whatever you want to call it. This particular example, we yanked from the microbial detail, page 5101. So, microbial retention practices should not be constructed until the contributing drainage area is stabilized. And here's the kicker. If this is impractical, and who defines impractical? Runoff from the disturb areas shall be diverted, and that's the key word here, diverted away, and no sediment control practice shall be used near the proposed location. So, as I already alluded to, silt fence is not a diversion. Filter cloth is not a diversion. Those are filtering practices. They will let the fine particles through and get into the footprint of our facility and contribute to clogging it up, as the photos I already shared illustrated. Again, as a soils guy by my background, I'm very familiar with what fine soil particles will do. If you've ever tried to vacuum up talcum powder or the dust that accumulates in a soils lab with a conventional vacuum cleaner that uses a filter bag or some sort of other filter product, the room will fill with dust because those particles pass right through the filter. So that's the same circumstance, same scenario that we're seeing when filter cloth or silt fence is used to quote unquote protect these facilities. Next slide. So again, I spent a lot of time on job sites over my career, from single family houses to million square foot big boxes and subdivisions and everything in between. It's almost always impractical to wait until a site is fully stabilized to put these practices in. So again, think about what that means, fully stabilized. In the context of a housing development, you've got single family homes or you've got blocks of townhomes. Typically, these practices are going to go in between the blocks of townhomes. They're going to go in common areas around the single family homes. The single families may have individual practices on their own lots, such as the rain gardens or dry wells. So just imagine, by the time the site is stabilized, well, everybody's moved in, the top coat paving is down, all the curb and gutter is down, the lawns are gorgeous, and it's just not feasible or practical to come back with a crew, excavators, dump trucks, et cetera, and install these facilities at that point. Okay, so they're going to get at least excavated, more or less, during the grading process. The contractor needs that dirt elsewhere. He he's there, he's going to do it. He's not going to move the dirt twice. So we fully expect to see these things, again, just because this is the way that things go on job sites. We're going to expect to see these facilities at least excavated. They may not get the filtering media put in, but they're going to be dug out. All right. So at that point, that's where we get into this protection scenario, because again, the surrounding area is not green, it's not grass, the site's not stabilized. There's a lot more construction to go on. So we get back to this diversion scenario, and the last bullet point again drives home: silt fencing and filter fabric do not divert. So they're not going to protect the facility. We may think we are, but we're not. And that's really the crux of what we're addressing today. So next slide, please. All right, there's a lot of text here, and I'm not going to read it to you. Again, this is pulled directly from the manual. There should be an overlay plan that identifies where all these facilities are, beyond just simply having them on the drawing and identified as a bioretention or a micro bioretention or an SGW or whatever the particular facility is. What I'm envisioning based on this text is probably something that highlights these, even if they're highlighted in some different color. On an, again, this doesn't have to be an extremely detailed plan. It could be on the stormwater plan. It could be on the grading plan. It could be on the sediment erosion control plan. Wherever it is, there should be a plan sheet, or as many as needed, hopefully not that many, that shows where these facilities are on any given site. And that makes it clear to everybody involved, from the contractor to the inspectors to whomever, where these facilities are and where we need to be advised that protection is required. Next slide, please. Now, we've talked about protecting excavated facilities. Let me back up just a little bit. Any facility, again, if it has an infiltration or a recharge component, we're depending on the native soils to absorb any runoff that we direct into these facilities, or some portion of it. Okay. Now, in the course of building a housing development or building a big box or what have you, there's construction traffic. All right. It might be pans, scrapers, end dumps, dump trucks. Who can say what's going to be running around on these jobs, and who can say where they're going to be running? Well, let's say you've got a series of dry wells or microbioretentions, behind the backyard lot of a row of homes. If you allow equipment to run on that area, it's going to compact those soils. Okay. So when the time comes to put these practices in, the soils that are there do not reflect the conditions that allowed the designer to determine that these will in fact infiltrate. Okay. Once you've compacted that soil, it's not the same soil. It doesn't have the same characteristics that it had when the initial borings or test pits or infiltration tests were run in the field. So again, to protect them at this point is pretty simple. You can just simply lay out some safety fencing around where each one goes. Again, no guarantee. Trust me, I've had my share of concrete cylinders run over in my day that I thought were thoroughly hidden and protected, but some guy on a rubber tire loader found them. Not on purpose. It's just the way sites run sometimes. Once we've excavated it, okay, then we really need to protect it. And that's the point where we need to start diverting the runoff around. Okay. We don't want any sediment laden runoff getting in the hole. And again, once you put media in it, same thing. You know, the media is in there. We don't want it filled up with runoff and muddy water. So, yeah, we just need to consider that. And, you know, the last point kind of drives this home. Is if you've got an infiltration component or a recharge component, the native soil is now part of the filter media. So, again, this seems pretty simple to me, you know, but just want to make sure everyone's clear on it. We don't want muddy runoff in these facilities. Next slide, please. Okay. What's going on here? This particular facility is a pure infiltration facility. There is no under drains in it. There's no control structure. There is no way for water to get out of this facility after it's constructed other than via infiltration through the bottom. Now, again, there's notes in the design manual that say when you're building these things, especially in this case, don't take your equipment into the footprint of the facility. This particular case, you know, this excavator, he's down in the footprint of the facility. He's working it, getting it, you know, shaped and contoured and brought to the appropriate grade. But he's tracking back and forth. He's twisting around. He could easily do that. And again, you know, the circumstances that we saw, he could have easily done this from outside. You know, reached in with his excavator and done what he needed, you know, did what he needed to do. But for whatever reason, you know, probably just ignorance. Nobody does things wrong on purpose, or at least we hope not. He's got his machine down in the hole, tracking back and forth, stirring it around, packing it down. You know, is that helping? I can almost guarantee that this facility is going to hold water beyond the time that it's supposed to hold water. Again, this is just an example of not disturbing the native soils any more than are needed. If this facility had a control structure and an under drain system, well, the bottom may very well clog up, but we're still going to get filtering through the media that we put in. But in this case, because there is no other way for the water to escape, you know, we may very well see this facility being reconstructed in a year or two. And again, everybody's moved in, everybody's living there. It's going to be an awkward and difficult and expensive situation to fix. Next slide, please. So, you know, how do we fix this? You know, how do we change what's going on in the field that we're seeing? There's been a couple of firms out there and a couple of jurisdictions that have kind of gotten ahead of this. And what we see here, this is a typical grading plan, and it shows a block of townhouses to the left, a block of townhouses to the right, and microbial retention number 22 is laid in right between them. Well, on this particular plan, they have identified that facility by using a red border, and they've identified the diversion, the protection, as DF, diversion fence, not SF, not SSF, not RSF, not smart fence. It's diversion fence. It's very clear. And again, the red sort of calls this out. So again, this is just an example of what could be done. It's at the designer and the engineer's discretion how they want to identify these things. But the point is, we need to make a better effort of identifying them so that folks know where they are and where they need to watch their step. Next slide, please. So again, that just blows things up a little bit. Clearly identify these practices on the plans. You know, if we don't know they're there, if the field people don't know they're there, they're not going to protect them. And if they don't recognize them, they're not going to protect them. I don't see this as a very heavy lift for the design community or the plan review community, but you know, we can talk about that when we get to the discussion point. Next slide, please. So the question was brought up earlier. What can we do? You know, what are the tools available to us? Well, the sky is practically the limit here. We don't the MDE and the design manual do not specify how you need to protect these things. All we're saying is don't let muddy water get into them. So any impervious barrier will work. The one that jumps to mind first and foremost is our detail in the sediment control manual, C9, diversion fence. Diversion fence is pretty clearly defined. There's a detail. It tells you how to put it in. It tells you what the materials are that it's composed of. And most people that install these controls should be familiar with it, because we often use it on the upslope side or the uphill side of the site to keep runoff from adjacent sites, clear water from getting onto our disturbed site. But it'll serve the same purpose around these facilities. Now, there's plenty of other ways to do it. The example that I like to bring up is when I was doing construction inspection full time, especially during the summer, you might have a water line or several water lines that you're bolting up in the middle of an intersection. Okay, you're bolting all the connections together. So you've got a fairly big excavation, and you've got a fair amount of infrastructure in that excavation, and it may take a couple hours to bolt everything up. Well, here comes a thunderstorm. It's summertime. This happens. Any contractor worth his salt is going to throw up a quick temporary soil berm around that hole to keep it from filling up with water, because he doesn't want to pump it out the next day. He wants to jump back in and finish his business and backfill it and go on down to the next intersection. So for these facilities, these stormwater facilities, a temporary soil berm would be fine. Or you could get really elaborate with that and work those berms into your sediment and erosion control plan. Failing that, again, any other method that'll divert, we've got a detail in, I believe it's in the sediment control manual for stream diversion built out of a concrete jersey walls wrapped in plastic. Again, I'm not suggesting that that's the most efficient way to protect the microbiome retention, but if that's what you've got available and you need it right now, it's perfectly acceptable. You could even use sheet piling. I mean, again, we're being a little silly and extreme here, but the point is, the objective is to, the objective is to divert water around it, not let the water get into it. So again, the sky's the limit, and the imagination of the people in the field is the only limitation on how to get that done. And just one more time, I want to run this home. It's silt fence and filter cloth do not meet the intent of a diversion. Not at all. So next slide, please. Now, this is an extreme example. This is just a photo I found of a plastic product that's used for flood protection or any other potential place where you don't want water. Again, I'm not suggesting that this is what needs to be done in the field. All I'm suggesting is it's a diversion. It's an impervious diversion. Now, yeah, I see a little bit of water leaking through this one, but if it was installed properly, I wouldn't expect to see that. But again, this is diversion is what we're looking for. Divert, divert, divert. Next slide, please. This is a profile view of the same example we saw a little bit earlier. Again, what's it showing us? It's showing us diversion fence. It's showing us where to put it in relation to the excavation, and it's highlighted in red. Again, is it necessary? I don't know, but boy, it does get your attention. And for folks whose job is to review plans all day, I'm sure at some point your eyes kind of glaze over. That's an interesting job to have, and I'm sure it gets repetitive. But the point being, we're trying to identify these things. We're trying to draw people's attention to them and let them know where the protection measures and practices need to be installed. Next slide, please. Again, a busy slide, and I apologize, but this we got this, found this in the course of our various trips around the state. This is a sample sequence, and again, I'm not saying that this particular sequence is perfect or a model or the one to follow, But what we're pointing out is it does address the timing on the installation of these ESD practices. Now, in this case, they're calling for them to be done after the road is boxed out and the base course and the curb and gutter are put in. And by off lot, again, we're talking about common facilities like the one between the two townhouse blocks. We're not necessarily talking about on lot. I'm sorry, I'm drawing a blank. Rain gardens or dry wells. So again, it would be helpful if the designers and the engineers could work this protection or address it in their sequencing. You know, we're not saying it has to happen, but it would make life easier for all parties involved. So something to consider. Next slide, please. So what's the bottom line, right? This is it. Any facility with a proposed infiltration component has to be protected from both traffic and sediment-laden runoff from the beginning of the job. Okay, that's what we talk about, putting the orange safety fence around them so they don't get run over by, you know, track loaders and end dumps and pans and dump trucks and any other heavy equipment that might be running around. Once the media goes in, same thing. No sediment-laden runoff can go in. It has to be diverted. And again, the point, it's real simple. We're driving this home. Divert, 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 divert. Next slide, please. All right. Looks like we got a point to open up for a little discussion here. So what do we got, Mr. Devon?
We do. Thank you, Pat. It looks like we had a few questions from our department here at MDE, and then another one unrelated to those. But I'll go back with the oldest one. Greg Kolaric from MDE asked, and he was referring to the excavator driving over the bioretention facility, the proposed bioretention facility. He asked if this constitutes a violation of the approved plans. And it looks like Amanda Malcolm from MDE also gave a great response to that. So if anyone's looking for an answer to that, basically Amanda said, Greg, I don't think it's a violation unless the ESC notes say that heavy equipment is not allowed. And then there's a little bit more in there, a little bit more of the conversation. But looks like Amanda kind of answered that very well. But we do have two more questions here, Pat. One's from Tesfa Michael. He asks, is the MDE surface storage table applicable to design of submerged gravel wetlands?
Boy, I'm going to defer. I'm just a soils technician. I'm going to defer that to one of our engineers who is more familiar with that portion of the design. That's not really my area of expertise, but it sounds like a very valid question. And if one of our other more astute engineering staff would like to speak to that, I throw the floor open.
Yeah, it looks like Stu here has his hand raised. Looks like he's hopping on an answer here. Go ahead, Stu.
Let me ask real quickly, and pardon my voice here today, guys. Is the MDE surface storage table, which surface storage table are you referring to? The one for erosion sediment control, or the one in the design manual for the design of these practices? Because what I would tell you is that there's, like any filter, there's a required reservoir above the filtering media. And in the case of a submerged gravel wetland, the gravel is the filtering media because of the muck that is needed to push the water through the filtering media. So if that's post-construction, then that is what is required. If you're talking about it as a sediment erosion control device, then you're talking about not necessarily a submerged gravel wetland, because hopefully the gravel's not in place yet, and you're just looking at a hole in the ground, in which case it'd be more of a sediment trap. Please let me know if that answered your question. If not, I'll try. Go ahead, Amanda. Somebody's gonna have to get Amanda because she can't. I don't think she can speak.
Let's see here.
Can one of our moderators open Amanda's mic?
There we go,
Michelle.
Amanda. I think you have capability now.
Tesfa just confirmed. His question is not relevant to erosion sediment control.
Yeah, thank you.
impacting the size of the BMP and design, and it wouldn't be applicable anyway, TESFA, to submerged gravel wetlands.
Yeah.
Sorry for the confusion, everybody.
No, that's good. No, my question answered it. It's the reservoir above the filtering media. Yeah.
All right,
Sure.
thank you so much for that, Amanda and Stu and Pat. Looks like we have a few more questions that were coming in as we were kind of discussing the previous one. We have a question here from Jeffrey Knob from MDOT. He says the use of the red color has specific contractual conditions on MDOT SHA projects and will not work to provide clarity. This can be done using notes or other means.
Sure. Again, the point is, you know, again, I appreciate everybody's got their set of rules that they have to play by. And we're certainly not asking anybody to go outside and color outside the lines. But the basic point is, again, based on what we're seeing and the guidance that's provided in the design manual, is these facilities need to be called out or identified in some way, shape, or form. Again, if a red coloring is not within your standards or your contractual documents, that's fine. It could be in the notes. The point is, we don't want it to be buried. You know, if everybody that's looked at a set of plans knows that there's 2 or 3 pages that are nothing but text that's full of notes. And in a perfect world, everyone on the job would be familiar with the parts they need to be familiar with. But you know, maybe it's enough to put a note at the beginning to make sure that this is discussed at the pre-construction meeting or at some other point. Again, what we're throwing out here today are just suggestions. You guys, this is your business. This is what you do every day. And, you know, we're telling you what's to be done and giving you some hints on how we think it might, you know, could work. But at the end of the day, you're free to you know, if it works, you're getting it, you're doing it right. So figure out what works for your particular scenario and follow that, I think is the message we're trying to beat home here.
Okay, thank you, Pat. And I apologize to Horatio Tablata, HT. Looks like I browsed over their question there. But they have 2 questions, Pat. The first one is, will MDE require additional protection on EJ areas? I'm assuming EJ, they're referring to environmental justice areas.
At this point, in context of the topic today, we're not getting into any new regulations. What we're discussing today is already in the manual. It's already in the book. You know, again, we're not promoting or suggesting that we're going to write any new regulations. There may be some clarity in future iterations of either the stormwater or the sediment and erosion control manual. But as far as today's discussion, I'm going to let Stu address that. He looks like he has a thought.
HT, hey, it's good to hear from you. Yeah, EJ, environmental justice, that's kind of beyond the scope of what we're talking about today, and we'll have to discuss that specific to any changes in either stormwater management or sediment erosion control regulations or those design manuals that are associated with them. But I did want to talk about what's the additional cost per acre by installing these new filters. I'd like to say that, you know, if you install them beforehand and for whatever reason your protections don't work and the filters fail, you know, what's the cost for per acre for installing a practice that didn't function? So, you know, having to re-excavate it and make sure it works down the road is unfortunately a necessary evil if we can't protect them up front. Our hope is that, you know, we don't have to build these things twice. We only have to build them once and then they're protected and function for the life of the development. But again, the other question you raised is very valid, and we'll have to deal with that as we proceed on a different front. Thank you.
Thank you there, Stu. Looks like we have another question from Anonymous here, anonymous source. The question is, since dry wells are considered an infiltration system, are you expected to keep heavy machinery off the area around a house during construction?
Again, this gets back to the logistics of this exercise. In a perfect world, yes. In the real world, you know, it's not going to happen. Even when you go to spread the topsoil on an individual house lot, you're compacting the soil. When you're grading, when you're fine grading around the house lot, you're compacting the soil. Hopefully it doesn't destroy things, but again, we're back to this, you know, it's a tough exercise, but at the end of the day, you know, you can only do what you can do. And again, I fully appreciate what, you know, the sequence that occurs. You know, you get to backfilling a foundation. Again, you've got a loader running around, or a bulldozer running around, or a skid loader, whatever the case may be. I'm not sure, you know, again, this is tricky, and, you know, I can't give you a specific or explicit direction on how to address that particular scenario, other than do your best, you know, protect it, but do your best. It's a tough call. Again, I appreciate the logistics there are difficult, and that leads to a bigger discussion that's kind of more philosophical, or in regards to these facilities and where we're putting them, and how the design philosophy is laid out. So I'm not going to get into that, but again, I'm just going to say, in the case of on-lot facilities, you know, protect them as best you can, and hopefully things will work out. Now, that's not a plan. I appreciate that. It's not a plan. That's not a policy, but I don't have a good alternative to give you at this time on that topic, in that scenario.
Thank you, Pat. I do see Amanda kind of added a little bit of answers to the anonymous question there. She just overall mentioned, or Amanda, did you want to kind of explain your answers there, or do you want me to kind of summarize them?
Mike, I wasn't writing anything in response to the anonymous question. Mine was totally separate. So do you want to go? I can
Gotcha.
Hand that back off to you, Devin.
Absolutely, Amanda. So Amanda mentioned that it seems to me that the key to successful construction is to break the BMP construction down into distinct stages. So for example, one would be to grade out the hole for the BMP during initial grading when the storm drain system is installed. And then second would be to complete the site work, etc., after which disturbed areas are stabilized. And then three, over excavate the bottom of the BMP to remove any accumulated sediment and scarify the ground. Then install the innards of the BMP, you know, such as the under drain gravel, under drain, and then the filter media, and so forth.
And that's a valid point. But again, you know, I go back to the fact that, you know, the foremen and the contractors that are orchestrating these jobs, sure, they're following the sequence, yeah, as best they can. And if they can't, hopefully they're going back to their engineer for an amendment or a change. But you know, I'm going to go back to the very basic principle here that, again, if we can protect these facilities, let's leave the dry wells in the yard aside for the moment. But as far as the larger facilities that are off lot, again, I just keep driving home the point. If we can keep the muddy runoff out of them, we're gonna be so much further ahead and so much further down the road toward a working facility. That you know, that's the focus that we're looking at here today. Go ahead, Amanda.
Oh, I just wanted to point out this. I was proposing this for BMPs where there is a situation where, you know, you're having where I mean, the issue that you're talking about, situations where people want to build the BMP up front, right? Not the ones where it's easy to wait till the end of construction to put them in the ground. So I'm talking about ones where, you know, it's basically the scenario that you've talked about. It's infeasible. It's just really practical. The reality of it is that the hole needs to be graded at the time of initial grading. So if that's the case, yeah, you can install diversion practices. Okay, things like pipe slope drains are something that I find to be really helpful, and diversion fence. But also hold off on putting that filter media in. You don't have to do the full BMP at once. You can break down the BMP construction, and the sequence of construction needs to reflect this, because the contractor has to follow the sequence of construction, and the inspector is making sure that the sequence is being followed. So this sort of breakdown and detail can be shown in the sequence of construction. I think that's a point that Pat, is coming back to time and time, just it's really important to get it in there.
Absolutely. And 100% agree with you, Amanda. As I said, there's no compelling reason other than, unusual circumstances or material delivery, logistics, et cetera. There's absolutely no reason to put the filter media in any earlier than you absolutely have to. And again, I appreciate the fact that the excavation will likely be done because it's a lot easier to dig that hole before the townhouses are constructed on either side of it. And, the job may need that material to balance as far as the cuts and fills. Who can say? Every site is unique. Every project is unique. And these our best guidance, again, that's why it's guidance and not necessarily hard and fast, because there are always going to be variations and circumstances that present a challenge. So, again, I leave it, the guys in the field, they do it every day. They're smart people. They know what they're doing. And if they know what we're trying to accomplish, they can come up with a plan to meet what we're trying to accomplish. And it's not our place to tell them how to do that. Again, I have faith that if we tell them what our objective is and what we need to do, they're going to figure out the best way for their particular circumstance to accomplish that. Go ahead, Nina.
I would love to hear some feedback from inspectors on that, because I think that this is something that I don't know how the inspectors feel about that sort of thing being developed in the field. I feel like it's something that needs to be on the plan. Yeah, I'm hoping some of our inspectors could write in about that.
Sure. And I go back to the fact that if the plans come out of the engineering office or the engineering shop with diversion fence on them and notes to that effect, hopefully that'll take care of that. Again, because of, I know how the the circumstances could change, in minutes on a site. I still go back to the fact that if you keep muddy water out of the excavation and out of the filter media, you've met our intent. But again, there's a lot of ways to skin that cat. The diversion fence to me seems like the simplest and the most straightforward, but again, I can't possibly, and no design manual can anticipate every single possible variation or scenario that may arise on a site. So if we keep the core mission in mind of keeping the muddy runoff out of the excavation and where possible protecting the footprint from construction traffic, I think that we're hitting our stride there.
All right, thank you, Amanda and Pat. Very healthy discussions there. We do have I want to move along to some more questions that we received during this time to keep moving along here. We have a question from Justin Valkos, and he mentioned piggybacking off of Greg's question from earlier regarding if that constitutes a violation of the approved plans. He said, as a sediment control reviewer, should we require language in the sequence that states no and/or minimal heavy equipment to be used within stormwater management facilities, areas throughout construction process, or something along those lines?
That's tricky. I don't have the manual open in front of me, but there are certainly portions of the design manual that speak to that. It's advisory. It's not regulatory, if I'm remembering correctly. We speak to it in the context of best practices versus requirements. So I'm not sure that we have a regulatory leg to stand on as far as making that a requirement on the plan. Now, certainly, again, I'm not an attorney. I don't write regulations, and I don't have to get them through the General Assembly and that sort of thing. So that's not my area of expertise. But again, put it this way, I'm not sure. We do mention it in the manual. It is part of the guidance. As far as making it a regulatory requirement or a requirement on the plans, I'm just not 100% sure of my footing as far as whether that would fly or not. I would certainly endorse and recommend any language that we can put on the plans that speaks to protecting these facilities. I'm just not sure if it can be enforced as a regulation. And I can certainly look into that and get back to you if that's appropriate. But again, everything I'm relating to today is in the design manual, so it is addressed. It's just a matter of, I think, people haven't really been paying that much attention to it. That's all, and we're trying to raise attention to that issue.
Thanks, Pat. We do have a few more questions. We have more of a comment rather than a question from RYRYSDS DFS. Comment is, I don't allow any infiltration devices to be installed until that drainage area is stabilized and built out. I will allow, if bios are connected with a solid pipe, I will allow that to be installed and covered with an end cap on both ends.
Okay, duly noted.
And then we do have some more, a few more comments here. John Tarr, looks like from PG Soil Conservation District. Afternoon, everyone. We typically require the sequence contain language relating to the protection of these facilities during construction up front and detail when they can be installed following appropriate stabilization. So
Sure.
it's like some more of our attendees just chiming in.
Yeah, and again, just let me pop in just real quick, Devin.
Sure.
Again, the focus here, and sequencing is great. That's absolutely a significant part of a good design. When the facilities are installed, again, I'm going back to what we've been seeing, and people seem to know that some sort of protection is required because we're seeing a silt fence around all these facilities. The point that we're really trying to drive home here is that silt fence doesn't cut it. Okay, it has to be a diversion. It has to be an impervious diversion to keep the runoff out of these excavations. And if nothing else, if we take nothing else away from today's discussion, take that away. So go ahead, Devin, with what else you got.
Sure. We have a few more questions, and I see that there are more coming in. And again, if there's any questions.
Let's do one more, Devin, and let's move on. Keep track of what we've got, and maybe we'll address some of the questions in the next section. The next section is going to wrap us up, so we can then just throw it wide open after we get through that. So let's do one more and then move on. How's that?
Sounds good, Pat. That works. So we do have a question from Chelsea Tyson from MDA. She's asking if we could talk about the MDE Stormwater letters sent out titled Administrative Continuance of Registrations under the Construction Stormwater, the 14 GP ending at the end of September. The letter does not give direction on where the amended 20 CP NOI can be found and filed. It gives a 9/30 deadline, which is in 2 days. I see Stu has your hand raised. So
Yeah,
do you want to take a stab at this?
I'm going to defer it. There are a couple questions about the transition from the 14 GP to the 20 GP. Please understand, this is not a cop out, but the general permit you're discussing, the 20 GP, is handled by our industrial permits section, most notably Paul Holovinka. I'm going to ask one of my staff if they can find maybe that contact information for you guys, and we'll put it in the chat here. But we can't answer that question today. And I did a quick look down the list, and I don't see anybody from that program or division. Thank you, Amanda, on this call so that they can answer it. So if you have those questions, I'm going to ask you to send your question to the link that Amanda provided. Thank you.
Thank you, Stu. And with that, I'll turn it back to Pat. And just as a reminder, we do have time after a few more slides here. When we get to the end of the presentation, we will have some more time for questions and discussion. Take it away, Pat.
Okay, next slide. So the concept or the topic of sediment traps was brought up earlier. Now, again, I'm not going to read off the slide, but here's the deal. If a proposed facility has no infiltration component, no recharge component, if we're not using the native soils as part of our treatment, feel free to use it as a sediment trap. The whole point of not letting the runoff in is we don't want to clog up those native soils and reduce their ability to infiltrate and recharge the groundwater table. However, once you put the media in, again, the media, this is expensive stuff, okay? And there's labor and there's effort to put it in. It needs to be put in properly. Once the media is in, you got to protect it via a diversion. Now, somebody brought up the SGW. Now, in the case of the SGW, yeah, this is a practice where we are specifically avoiding infiltration. If you design an SGW and the soils that are underlying it are going to take water out of it, how are you going to maintain your elevation? So in the case of a submerged gravel wetland, absolutely. And let me relate something that I ran across. I had a project that was a fairly large project, probably 10, 15 acres or so. And the only real significant sediment erosion controls on it were perimeter silt fence. It was actually super silt fence, but the point being, it was a perimeter control. And we got some pretty big rain events, and the 3 foot tall super silt fence, so much water got up against it that it overtopped. Okay, and muddy water went out all over the road, downstream into a creek. It was a mess. However, right at the bottom of the site, where you would expect it, was a fairly large proposed submerged gravel wetland. And my question when I became aware of this to the people involved was, why didn't you put a trap in where the SGW is proposed? And I was a little disturbed by the response I got. And the response I got was, well, we can't do that because we're not supposed to install these practices until the project's done and the surrounding area is stabilized. So that kind of got me thinking, I don't know that everybody quite understands how an SGW is supposed to work and what our intent is. In that scenario that I described, it would have been perfectly acceptable and probably very effective to excavate that SGW and use it as a sediment trap rather than relying on simple silt fence as a perimeter control at the bottom of a fairly long slope. So, get familiar with these practices, understand how they work. And again, a lot of this stuff should come clear. That would also apply to any other filter practice that's servicing a hotspot, all right? Or if you've got class C or D soils where you have absolutely no expectation of infiltration or recharge at that location. If that's the case, by all means, excavate it, use it as a trap. At the end, when you're ready to convert it, you do it just like you would the old school large detention basins that did double duty as a trap. You restore it to its original contours and design, install the media and other infrastructure. At that point, again, if the surrounding area is not stable or there's a potential for muddy runoff to get into it, you got to put up your diversion. Okay. Hopefully that's clear. And again, we can discuss that more at the end when we get into our round robin discussion. Next slide, please. All right. What happens when we fail to divert, when we let muddy runoff? Now, these two examples, I'm not going to say that either of these failed strictly because they were compromised or they weren't protected during construction. But this is what we're going to see. All right. And we do see this. I'm sure that in the audience, you guys can point out, any number of these filter practices that hold water. These things are supposed to drain down within 24 to 48 hours or so, 72 hours at the most, at the absolute most. But, here we've got a facility on the left, and this facility even has under drains because we can see it's got a control structure at the end of it. Why it's not draining, again, I can't say, but I can say that if you don't protect your facilities, either the subgrade that's supposed to infiltrate and recharge or the media once it's been installed, this is what you're going to get. The photo on the right, I was talking to these guys that are pumping this thing down. They said this is the third time that they had pumped this facility down and rebuilt it. Again, and there's no control structure in this one. The only way water can get out of this facility is out the bottom through the native soils. So one of two scenarios has occurred. Number one, as we're talking about, it's very possible that those native soils were exposed to muddy runoff. They got contaminated, and they're no longer infiltrating the way they were when the initial soil borings or in-place infiltration tests were run to demonstrate that practice will work here. The other one is it's very possible, and again, we've seen this, and I know it happens. People aren't field verifying, field proofing their designs. If you're going to design a facility that is intended to infiltrate, you really, and I believe this is regulatory, you should run an in situ, in place infiltration test to demonstrate that it's going to work. I think what we see, and again, I'm guessing here, but it makes sense, is designers are using soils maps to determine what the soils are at a particular location. And I got to tell you, as an old soils guy, the maps just aren't detailed enough. There's just, it's been 50, 60 years or better since those maps were developed. You can't possibly drill enough holes in the world to get that accurate of a picture of what particular soils lie on any given site. And again, who knows what sort of grading or earth manipulation or movement went on between the time the soils maps were generated and now. So this gets back to the point where, let's make sure as designers and as engineers, and again, this is how I used to do, it's what I used to get paid for. You need to verify that the conditions are going to work for the design that you're proposing. That's critical. If you make an assumption, you could very, very well end up in a situation like we have here. Or if you have a good infiltratable subgrade, it's sandy, it's sand and gravel, it's porous, but if you allow it to get clogged up with fines from runoff, it's not going to work. So two caveats there. Thank you, Amanda. That's great. Again, I spent a lot of time in the field specifically running in-place infiltration tests to tell my engineer bosses whether or not their design was going to work in a particular location. So again, I can't speak for how other firms operate. I can't speak for what the industry default practice is, but I'm here to tell you, if you don't actually dig a hole where you're proposing to put an infiltration basin, you're rolling the dice. And I'll leave that at that. Next slide, please. Okay. What's going on here? We've got a microbiome retention here. It's got under drains. It's got a control structure. And it's been in for quite some time. We can assume this facility is fully constructed. The filter media is in. The under drains are in. It is built. But look at it. It's holding water. It's holding water to the point where we've got a robust crop of cattails and marsh vegetation. Okay. Look at the look in the foreground. Yeah, we've got seed and straw down, but I'm not going to call that stabilized. I hope nobody else would either. Next slide's going to back up a little bit and show us some context. Go ahead. So here's the next slide. Again, there's plenty of opportunity for muddy runoff and soil to get into this facility, contaminate the media, potentially contaminate the the underlying subgrade soils, and this is what we got. Okay. Again, if this facility had been constructed and had an impervious ring of diversion fence around it, we probably wouldn't be where we are. But this facility is going to have to be rebuilt. Again, it's kind of offensive from, again, somebody's paying for it and somebody's making money to do it, but we're burning a lot of diesel. We're it's just, why do things twice? It just doesn't make any sense to me why anyone would do things twice unless some extraordinary circumstance demanded it. Next slide, please. Okay, that brings us to the end. I want to address one more point before we get into the the further Q&A. On bioretention soil mix, we do not, number one, we get a fair amount of questions in our office. People are asking us, hey, do you guys start, I'm making bioretention soil mix. I'm a landscaper. I've got a yard, a mulch yard, et cetera, et cetera. I sell sand and peat and topsoil, and I want to make bioretention soil mix, and I want to know how to get it certified. Well, there is no such thing. There is a specification for bioretention soil mix. It's very specific in the design manual. It provides proportions for how much organic content it's supposed to have in it, how much sand it's supposed to have in it, what kind of sand it's supposed to have in it, pH, soluble salts, a bunch of parameters. We don't receive samples of this stuff and evaluate it and provide certification, okay? If you are in a situation, or if you have contractors or suppliers that are looking to get a quote unquote certification or approval on their product, my suggestion is they should hire a third-party engineer, soils engineer, or whoever has the capability and the facilities to sample their product and evaluate it and determine if it meets the specification or not. If it does, the engineering firm writes a letter, the engineer puts his stamp and signature on it, and one will assume that for a period of time that the materials coming out of that particular manufacturer or distributor are acceptable. Now, this gets a little complicated, or rather it gets a little odd. We do not require this bioretention soil mix to have any sort of certification, okay? We even allow it to be mixed on site. So, for example, you bring in a truckload of sand, C33 sand, you bring in a truckload of peat or topsoil or leaf grow or whatever the case may be, and you've got a guy running around with a skid loader, taking a bucket of this and a bucket of that and kind of stirring it around a little bit. Well, I'm here to tell you, that may be acceptable under the regulations, but it's a bad way of doing construction. Imagine, there's a reason that concrete, which is another product that is composed of specific proportions of water, sand, gravel, and cement and admixtures, there's a reason that stuff is made in a plant where they have scales and screens, and they can control their proportions so that they know when it comes down the chute, it is consistent with what the specification is, okay? In the course of my career, I got to see the introduction and evolution of soil modification in the state. Typically, we've used up all our good sites. All the sites left have bad dirt on them for whatever reason. It's very fine, silty soil. It's got a high moisture content. And the first thing that we started seeing was the addition of hydrated lime. Hydrated lime, when it reacts with water, generates an exothermic reaction. The dirt gets hot and it cooks off some of the moisture into the atmosphere and will lower the moisture content of the soil to the point where it can be effectively compacted in an engineered form. Well, when they first started doing this, same thing. A 953 track loader would throw a load of dirt into the trench, and then he'd get a bucket full of lime and throw that in the ditch. And then he'd walk in there and kind of stir it around a little bit. And you've got pockets of lime, you've got pockets of dirt. It's not mixed. It's not even close to being mixed. And the results reflected that. And we saw the same thing with soil cement treatment. Okay, soil modification with soil cement. You guys are riding around, breaking open bags of cement and sprinkling it willy-nilly over the area to be filled, and then back dragging it with a loader bucket. And again, we're not getting the results. This stuff has to be mixed. The proportions have to be controlled if you want a good product. So again, there's nothing that says you can't mix it on site, but if I saw that, I would strongly discourage it. Again, because the odds are it's not going to be thoroughly mixed. It's not going to meet the specification when it's all said and done. And most importantly, it's probably going to fail and somebody's going to have to pay to fix it. So just one last thing I wanted to touch on before we get into any other Q&A. So with that, let's have it.
Thank you so much, Pat. Looks like Stu has his hand raised in regard, I think, to your last comment here, Pat.
No, actually, I kind of want to jump in while I'm thinking about it.
Yeah, go ahead, Stu.
We got a number of questions about the 20 construction zone permit. I want to just be clear. The 20 construction zone permit and anything that in it that is different or in extra to what is required through the normal course of the 2011 standards and specs in the erosion sediment control program. The local inspector is not required to enforce the 20 construction zone permit. That is MDE's compliance program that is responsible for doing that. And that's a common question. I'd like to point out that Michelle Crawford placed in the chat box a link to the webpage for our wastewater permits where it talks about the 20 construction general permit. And there's a number of resources off that page that talk about who is doing what and where you can find more information. So again, if you have any questions about the 20 construction general permit, I strongly encourage you to go to that website. Again, it's pasted in the chat box and look up the information there and then go from that point. But again, if there's something on the 20 construction zone permit that's in addition to what is normally required in a standard erosion sediment control plan, that would be enforced by our compliance program. That's all I had to say. Thank you.
Thank you, Stu. A few questions that we got,
Devin,
before. Yes, Pat.
I just want to throw out one last disclaimer before we get into this.
Yeah, go ahead.
I go when I pull pictures to use in these presentations, I try very hard to not identify the jurisdiction where they were taken. That's not our objective. We're not trying to throw shade on anybody. So if you see any photos ever in the course of one of our presentation that you recognize as being from your jurisdiction, you don't have to admit to that. Okay. Again, we're using them for examples. They're generic examples. We see them where we see them, but again, we go out of our way and try very hard not to present any photos that would specifically identify where or whose jurisdiction they were taken in. So, if you see a picture that's from your shop, no need. You don't have to fess up. There's no need. Okay, and we're not picking on you. We're just pulling pictures that illustrate the points that we're trying to drive home. So just wanted to get that out there and make sure nobody feels like they're, being picked on or singled out or anything else. These are generic photos as far as we're concerned. They can come from anywhere. So with that said, go ahead, Devin.
Thank you, Pat. I'll go with the oldest question that we have on here on my list. It's from Jeffrey Knob. And again, I apologize if I mispronounce anyone's name. I know that my last name in itself is hard to pronounce, so I know how that goes. But Jeffrey Knob has a good question. He's asking if there's a training available that we can give to our construction inspectors and contractors. If no, can we work together to develop one? I understand this is an overarching issue MDE is seeing. We can do our best as reviewers, designers, but we need the construction side on board.
Absolutely. And I would encourage such a thing. And I will say, and I'm going to be diplomatic, I will say that MDE is working on several guidance documents and manuals that will go a long way toward educating the community broadly, from the design side to the inspection side to the contractor side. We're working on it. In the interim, and actually the following slide after we have our discussion is going to speak to this, but in the interim, I am more than happy to entertain any suggestions, any ideas, any better ideas, any comments, critiques, concerns from anyone in the community. Again, from the design side all the way down to the field inspectors and plan reviewers. Hit me up. My email is right there. My mobile number is right there. I'm happy to entertain anything that the community has to offer. Again, with the caveat that we are working on several documents, but I can't say with any specific degree of certainty when they will be ready for prime time, but we are working on it.
All right. Next questions from an anonymous. They're asking, would installing salt on side slopes inside the stormwater management device with reinforced silt fence installed along the perimeter, would that be sufficient to keep particles from infiltrating the filter cloth placed over the filter media?
Okay, so the scenario we've got here is we've got a facility that's constructed, okay? The media is in, okay? We've covered the media with filter cloth. We've put sod on the inside slopes of the facility, and we have put super silt fence around the top of that slope. I think that's a fair description of what was described, but I'm going to go back to, if the area outside of that super silt fence, outside of that sod, is not stabilized, if it's bare dirt, you're going to get soil particles, fine soil particles are going to come through the super silt fence. Yeah, are some going to be caught by the sod? Sure, but it's still not meeting the intent, and you're still leaving yourself open to contamination and loss of performance. Again, if I understand the question being posed, that would be my response.
Thank you, Pat. We have one last question here on my list. It's from Don Dorsey from Frederick County. He's asking, he's more or less saying, historically, contractors try to wrap the underdrain pipe with filter fabric versus using appropriate stone around the underdrain pipe, or a design consultant adds a filter fabric detail around the underdrain. Typically, in 5 years, these filter fabrics get clogged and then cause these issues.
That's 100% correct. And I will go back to what does the plan say? What did the engineer ask for? And what does our detail say? We you know, during the evolution of this process, and I was around when these ESD practices first started going in, probably 10, 15 years ago. Filter cloth has been problematic from the beginning. And again, our details, unfortunately, some of them still do show horizontal layers of filter fabric between media layers. Hopefully everyone's gotten the word that doesn't work. That will clog up so quickly, even under normal filtering duties from a stabilized drainage area. As far as what the contractors are, again, once the underdrain pipes are buried, nobody's going back to take that filter cloth off of them. So I would suggest if they're seeing that, I would hope that the field inspectors, whoever they work for, whether they're a third-party consultant, whether they work for the county, the township, the state, for MDE, I would definitely throw a flag on that. That's unacceptable. It doesn't meet the detail. It's not consistent with the detail. And as Don just said, we know they're going to clog up and fail. And here's the thing: think about the design. If you've got a filtering practice that has under drains, but also has a sump under them, a stone sump that is, basically we're trying to get some recharge, but we've also put the under drains in almost as insurance, so that if the infiltration capacity is lost and we're not getting water out of the facility via infiltration, then rather than the facility fail and have standing water on it, the filtered runoff will still be intercepted by the underdrain and in its treated form sent downhill into the system or to daylight. If we compromise the underdrains, then we're going to end up again with a facility with standing water on top of it. Now, everybody's got a different agenda. I would love to have a facility in my backyard with standing water on it. I don't mind the mosquitoes, and I love the habitat and the wildlife. I think it's great. Other people, 100% opposite. They do not want that, and that's fine. Again, that's fine. But the point being, the facility's not working if it's got standing water on it. It's not functioning. And I'm going to do one last little piece of editorializing here. Again, I've been around a long time. experience is just an accident of longevity. So the longer you hang around, the more stuff you see, the more you learn. Sediment controls and stormwater management culturally do not get the respect that the sexy engineering does. Okay. When you're given a piece of property and you need to fit, as many houses on it as you possibly can, or you need to design a water system that may have challenges, or a sewer system that may be challenges. The best and the brightest are working on that and designing that, and they fully expect that when it is fully constructed, it's going to work in perpetuity. All right. When you design the foundation for a skyscraper, it represents you and your work, again, in perpetuity. If it falls down in 10 years or 15 years, that's not doing it. That's not getting it done. Sediment control and stormwater maintenance and design do not carry, as my observation, again, over the last 25, 30 years, do not carry the weight that some of the other disciplines and objectives that the designers have to meet. It just doesn't get it. Now, again, this is changing. I've seen a lot of cultural changes in this business over the last 30 years. And we're getting there, but it's still these two disciplines are sort of bringing up the rear as far as priorities. When you design a sediment, or when you design a stormwater facility, other than routine maintenance that's to be expected, that facility should just work. Okay. We should not be digging these things up 5 years, 3 years after the fact because something's gone wrong, either in the execution of the construction or some other factor. They should hopefully someday. Sediment control, the guy designing the sediment control should have as much experience as the guy that's designing the water and sewer system. We're getting there. A comparable example, and I'll step away as soon as I finish this. A comparable example is safety culture on job sites. When I started out, the standard uniform on any construction site was shorts and a pair of boots. Granted, most of the workers were male, but a hard hat site, you didn't see that unless you went onto a federal job or maybe a state job. As far as equipment, rollover protection, trench boxes, trench protection, safety issues, none of that stuff, that stuff is all evolved. We've seen it evolved. I'm now to the point where I feel naked if I go on a job site without a hard hat. 20 years ago, it was an imposition. So hopefully we'll see that evolve as time goes on, and people will start to take a little more care and due diligence and an eye toward longevity and the importance of building these things properly at the beginning to give us long-term performance that we're looking for. And I'll leave it at that.
Thank you, Pat. And looking at the questions, it looks like we have no more questions here. Looks like Michelle just went on to the last slide here. So if any of you guys have any outstanding questions, again, feel free to ask them while we're going over the slide. And as always, you have Pat's contact information here. But go ahead, Michelle, take it away.
So thank you to everyone, for your thoughts today. We did schedule this until 4. So, if you think of more questions, feel free to type them in or raise your hand. And as Pat said, we welcome your feedback in the next few weeks as we put the final touches on the guidance documents, and we will make an announcement when it's released. I do see another question, so I'll hit pause.
Yeah, we just got a question in from Mark Wells. Mark is saying, in regards to the sod being placed, what if the outside of the silt fence is seeded, straw, and tacked?
Seeded, straw, and tacked with a T? Not packed with
correct.
A T. Not packed with a T. Okay.
Yeah, TACKED. Yep.
I'm gonna again. This is a scenario that is going to be unique from practice to practice to practice and site to site to site. If, in everybody's best professional judgment, there is no opportunity for sediment-laden runoff to get up against the silt fence, again, we're back to you're rolling the dice. Maybe it'll work out, maybe it won't. But again, I would hope that common sense and an understanding of what we're trying to avoid will rule the day. Again, the simplest way I can present this is, regardless of what you do, what sequence you're bound by, what your site limitations are, et cetera, et cetera, et cetera, don't let cloudy runoff get into your facility. If you follow that simple mantra, we've met our objective. And I don't mean to be flip, but again, it just gets back to, that's the objective. That's what this whole presentation is about, is not letting contaminants get into our facilities before they're ready to accept the contaminants that they are designed to handle, which in this case is going to be stormwater runoff from a stabilized area, whether it be pavement, grass, rooftop, whatever the case may be. Stu,
I see you have your hand raised.
Yeah, just with respect to this last one from Mark Wells in regards to sod being placed. Well, first of all, I would like to say, if it is Maryland certified sod, then certainly it can be placed. But the other thing I'm going to point out is, just because you're putting sod down doesn't necessarily mean it's correcting the problem. We've been to a number of sites in the last couple of years where sod has been placed. They sprinkler the sod to grow. The water flows through the sod, and because there's no topsoil below it and no, basically the soil has been driven around by equipment, the water flows right off and causes an erosion or rill right at the edge of the sod and into whatever practice it's in. So, I just want to point out that just because somebody's throwing sod down onto a site, let me rephrase that. Just because somebody is throwing Maryland certified sod down onto a site does not necessarily mean that site is stabilized. I think we need to start thinking about what the intent of what we're trying to do here is, and not just the fact that, oh, look, there's this nice piece of green sod there. So thank you for that. The other thing I wanted to mention about the underdrain pipes and the filter fabric, anytime you wrap a piece of filter fabric around something, in order for water to flow through two distinct surfaces, it has to totally saturate the first surface before it starts flowing through the second surface. That's one of the issues with filter fabric and why it clogs. I was just telling a colleague of mine that there's been an evolution of materials. If you're using a drill pipe, they're out in the field using a drill to poke holes in the pipe, that's going to probably need to be wrapped by hardware cloth. But that wrapping in hardware cloth is to keep the stone jacket that surrounds the pipe from filling the holes. You can get slotted pipe now. If you're using slotted pipe, you don't need that hardware cloth. You can usually typically backfill it with gravel. Heck, we've seen sites where they've used screened well pipe. If you're using screened well pipe, you can backfill that sucker with filtering media or sand because of the screening on the well pipe. So again, you have to look at the materials that are being used on the specific site and how they're being used to determine what type of protection. One size does not necessarily fit all. Again, it comes down to what is being used and where it is being used. So I thank you.
And I'm going to piggyback on what Stu just said. His point is very valid. Think about sod. When you put sod down, you're putting it, whatever you're putting it on, until the sod actually interfaces with what the subgrade is, until the roots start penetrating that underlying soil. Basically, you've got a flow channel between the two. And as Stu, certified sod, absolutely. And as Stu indicated, we see quite a bit in the field situations where sod has been placed on a slope. It's been watered. It's green. It's looking good. But the sidewalk below it is completely stained from fine particles that have been picked up and are being transported in that interface, that space between the fresh sod and the underlying soils. Again, is the volume huge? No, it's not huge. But the point being is, every little bit of fines that we let get into our facilities before they're ready to accept it is going to cause a problem. Again, we should not. The objective is to not handicap these things before they get a chance to do what they're designed to do. So, just something to keep in mind. Just because you put sod down and you tack it down and you water it and it's green, doesn't mean you're not losing soil from underneath of it. So with that said, proceed.
Thank you, Pat. Looks like we have more of a comment versus a question from Anonymous. They're saying under drain, perforated pipe versus solid under drain for micro practices. So,
Okay.
but as for right now, I don't see any more questions. Maybe at the remainder of us going through this slide, there might be more that pop up. And again, if you guys, can't think of any right now, you sleep on this a little bit, feel free to, go ahead and reach out to us with any questions you may have if you didn't get a chance to answer, to ask it during this presentation. But with that, I want to turn this back to Michelle.
Sure. This is a great discussion. We weren't sure if we would get some engagement or if we would, use all 2 hours. So it's really great to see all these thoughts coming in and all these suggestions. So, we will make an announcement when the final guidance document is released. The slides and the recording of today's session will be posted on our website. And I shared that here on this slide. And that will happen as soon as we can process it and post it. So that might be a little quicker than finalizing the document. If you'd like to come back and check our website in the coming week or two. And, as we've been saying, we encourage you to share this information, to get the word out. We are discussing this issue during this fall's visits to locally delegated programs who are up for review. And you might have noticed some of the dates on some, but not all of these photos, that process has begun, and we've seen this issue is occurring. We are observing in the field, but as Pat said, of course, we're not trying to call anyone out here. We are truly seeing this issue across the state. And we hope, today's discussion is the start of evolving everyone's understanding of what needs to be done, moving toward better processes, and from that, better stormwater quality, and ultimately healthier waters. And I wanted to mention that at some point in the future, this guidance will be incorporated into the updated standards and specifications for erosion and sediment control when those are revised at some point. And I think Pat might have mentioned, we plan to do more outreach sessions like this in the future that focus on a single topic and that provide some further guidance or clarifications based on what we're observing or whatever is brought to our attention. And those future sessions like today will likely be around this time of year to align with our delegation review visits. And so we welcome your thoughts on future topics. And it looks like there are more questions arriving.
It looks like Stu put an answer here to our one question we got from, again, I apologize if I mispronounce your name, from Rolla. But yeah, basically any questions related to the 20 CGP, please feel free to, and we encourage you to use those links that we provided in the chat earlier.
If I could just add to that, what our understanding is, program review, we can't speak for the compliance shop, but what we have been told is that, that operators must apply for the new construction general permit if they are currently covered under the 14 GP. That will expire, and they have until, like you said, the end of this month to apply for that on the ePermits website. And if they don't, there is no automatic rollover, that permit coverage will be terminated. So please, if you know of anyone who needs to apply and is currently operating, then please, advise them to get in touch with the compliance program, to check on that website and get that process started.
Does that bring us to a conclusion, Michelle? Barring any further questions in the chat or hands raised?
No, I'm not seeing any more questions or chats.
Okay. Again, just to reiterate what Michelle said, we want to hear from you guys. We want to hear what you're seeing. We want to talk about what you're seeing. We want to hear your ideas. Something I tend to preach is, you know, everything that's in the design manual or in the guidance that we've generated were simply the best ideas that we had at the time of publication. And as you know, the design manual is the original part is 20 years old. The rest of it's from 2009. The sediment and erosion control manual is from 2011. The world moves on, life goes on, everything changes. You know, the only constant is change. So we want to hear from you. We want to know what's working, what's not working, what you're seeing, et cetera, et cetera. So please feel free to reach out to us. It's you know, we're not gonna bite back. We want to hear. So please keep that door open. It's open on our end, and we encourage it very much. So please talk to us, and we want to hear it. And that's all I have.
Thanks so much, everyone, for your time.
I'm going to say just this concludes our presentation for the day. And as Michelle said, thank everyone for your time, and we appreciate your attendance very much. And hopefully some things were learned. So again, feel free to reach out to any of us if you have any questions or concerns or ideas, and we're happy to entertain them. And again, thanks everybody. Appreciate your time.
I will hit stop on the recording now.